This is the beginning of Chapter 2, Inequalities. Our very first lesson is a reintroduction of inequalities, how to graph them on a number line, how to write an inequality given the picture of a number line, and some basic solving of inequalities. So a reminder that an inequality is a statement formed by placing an inequality symbol between two expressions. Here is an example. We've got one expression, y plus 5. The other expression is a constant number, and we have an inequality symbol in between it. Here's your reminder of the four inequality symbols that we use: greater than or equal to, less than or equal to. The answer to an inequality is the set of all numbers, which is why we have a number line, because there's more than one number that makes a statement true. It can be shown by marking a graph on the number line, and the shaded region on the number line represents the solutions. When we see greater than equal to or less than equal to, we use a solid dot because the number is part of the solution. When we see just greater than or less than, we use an open dot because we don't want to include the point because it's not part of the solution. So our first set of examples is graphing inequalities. This first one says 3 is greater than x. So because it's this symbol, greater than, we're going to use an open dot. I'm going to put my open dot on 3, and then I have to decide what direction to draw my arrow. I'm going to test. I'm going to choose a number just to the left of 3 and just to the right of 3 and see which one makes sense. I can say that 3 is greater than 2 or 3 is greater than 4. And ask myself which one makes sense. Well, 3 is greater than 2 makes sense. So that means I need to take my arrow and draw it in the direction that the 2 is located, towards the left. In our second example, this says y is greater than 2. Once again, there's no equal bar, so we're going to put an open dot. Got my open dot on 2. I'm going to test the values of 1 and 3 in place of y to see which one makes sense. Does it make sense to say 1 is greater than 2 or 3 is greater than 2? Well, it makes sense to say 3 is greater than 2. So that means my arrow needs to go on the same side where the 3 is located. Here's our next example. 4 is less than or equal to x. Since there's the less than equal to sign, we need a solid dot. I'm going to put that on 4. And then I need to test one number on either side of 4. So is it true that 4 is less than or equal to 3, or that 4 is less than or equal to 5? Well, the second one makes sense. 4 is smaller than 5, so that means I need to draw my arrow in the direction of the 5. Our last example here, y is greater than or equal to 2. Greater than or equal to sign, need a solid dot. I'm going to put my solid dot on 2. I need to test which one makes sense. And so I'm going to put in a 1 and a 3. Does it make sense to say that 1 is greater than or equal to 2, or does it make sense to say that 3 is greater than or equal to 2? Well, it makes sense to say 3. So I'm going to draw my arrow off to the right. Now I've done some other examples here. Number 5, I need a solid dot on -5, and I had to test which one made sense. So I tested -6 and -4. And the true statement is that -6 is less than -5. So I drew the arrow off to the left. In example 6, we need an open dot on 1 because it says greater than. Test 0 and test 2. Is 1 greater than 0 or is 1 greater than 2? Well, 1 is greater than 0, so that means I need to draw the arrow off to the off to the left. Last example here. -3 less than or equal to x. I put a dot on -3, closed dot, and then I'm going to test -4 and -2. Is -3 less than or equal to -4, or is -3 less than or equal to -2? Well, it's this one here. -3 is smaller than -2, so I draw my arrow pointing to the right. So there's graphing inequalities. Our next set of examples asks us to write the inequality that's graphed. So I see an open dot on -3. I'm going to put a variable and I'm going to put -3. And then I have to ask myself, all of these numbers over here to the right, how do they compare to -3? Where all of those are bigger. So I need a greater than sign, and because that dot is open, I just need greater than. I do not need an equal bar in there. Is 2 a solution? Well, here's 2. Is it covered by the number line or covered by the solid arrow? Yes, it is. So I'm going to say yes. Question 9. I have a solid dot on 4. So I'm going to start with X, put 4. How do all of these numbers underneath the arrow compare to 4? Well, all of those are smaller. So it means I need a less than symbol. Because that dot is solid, I need to put the less than equal to sign. And the question is 4 a solution? Well, since there's a solid dot on 4, that means 4 is included, so I say yes. Example 10. This is the number -2. So I'm going to put X, -2. All of these numbers underneath the dark arrow are smaller than -2, so I need to put less than. That's a solid dot, so I need to put less than equal to. And then the question is 1 a solution? Well, here's 1. It's not underneath the arrow, so I say no. In 11, that's supposed to be a solid dot pointing towards the right. So all of these numbers are greater than -2, so that's what I wrote, X greater than or equal to -2. And 12, this dot is kind of unclear. It's supposed to be an open dot, and the arrow is pointing off to the right. So that open dot is at 11. All the numbers to the right are greater than, so I'm going to write X is greater than 11. Back in question 11, it asks, is -2 a solution? Since there is a solid dot on -2, I'm going to say yes. And in 12, it says, is 7 a solution? Well, 7 is here. It's not underneath the arrow, so we have to say no. The next example, checking a solution. Does 8 make this statement true? Well, all I'm asking you to do is take 8 and put it in place of X. So we write -7 plus 2 times 8, and I want to know, is that less than 9? Well, 2 times 8 is 16. -7 plus 16 is 9. So I ask myself, is 9 less than 9? No, 9 is equal to 9. There's not an equal symbol in that, so I have to say no. Example 2, test -3. Put it in place of X. 2 times -3 is -6. -7 minus 6 is -13. Is -13 less than 9? Yes, it is. Example 3, if I place in 10, I end up getting that -7 plus 20, which is 13. Is 13 smaller than 9? I would say no. So that's a simple test to see if this solution works. Very similar to what we've done with equations. Now we get to the solving portion of inequalities. In this first example, we know that 5 is bigger than 2. If I add 3 to both numbers, I still end up with a scenario where the number on the left is bigger than the number on the right. It hasn't changed the relationship. I might have changed values, but I haven't changed the relationship. In the second example, -3 is smaller than 6. If I subtract 5 from both of these numbers, I have -8 and 1. Well, -8 is still smaller than 1. I haven't changed any relationships in the comparison of the numbers. When I multiply by +2, 4 is smaller than 7, 8 is smaller than 14. The relationship hasn't changed. If I divide by 2, 6 is bigger than -2, 3 is bigger than -1. The relationship still hasn't changed. If I multiply by -3, 3 is bigger than -1, but when I compare the products, -9 is smaller than 3. A change occurred. That's a concern. We have to take that into consideration when we move forward. If I divide by -1, well, I start where -8 is a smaller value than -2. When I divide everything by -1, I get 8, which is bigger than 2. The relationship changed again. That's another concern we need to take into account. And the key to this is that when you multiply or divide by a negative number, like we did in these last two examples, we have to change our inequality sign in our answer. And that's the process that we're doing back here on this last page. There are 9 problems to solve. Each of them we need to solve for x using our solving skills that we learned in Unit 1, and then graph our answer on the number line. So in this first example, we're going to subtract 3, divide by 2, and we get the statement x is greater than -2. Now you'll notice this number line doesn't have any numbers on it. Take this value here, put it in the middle. Think of a number line. You know that as you move to the right, your numbers get larger. As you move to the left, your numbers get smaller. So there's my number line. I need to put an open dot on -2. This one's numbers bigger than -2. So I can test, is -3 greater than -2, or is -1 greater than -2? Well, -1 is bigger than -2, so I draw my arrow to the right. Question 2, we have to add 5 to both sides. And we're going to multiply by 2 to get rid of our fraction. And we get the statement x is less than or equal to 2. I'm going to take 2, put it in the middle of my number line, count like normal. This requires a solid dot on 2, and then I have to decide what direction to draw my arrow. So I test 1 and I test 3. Which one is a true statement? Well, it's true that 1 is smaller than 2, so I'm going to draw my arrow to the left. Question number 3. Don't move this x. Since it's a simple inequality, we're going to leave that x where it's at. I'm going to move the 18 by subtracting. And 45 minus 18 would be 27. So we get 27 is less than -9x. Dividing by -9. Now on our previous page, we said if we divide by a negative sign, we flip our inequality symbol. So that right now says less than. I need to flip it to say greater than and bring down the x. Notice the x started on the right-hand side of the inequality. I had never moved the x, so it ends on the right-hand side of the inequality. Take -3, put it in the middle, make my number line. I need an open dot on -3, and now I have to test. Is -3 greater than -4, or is -3 greater than -2? Well, -3 is bigger than -4, so that means I have to draw my arrow in the direction of the -4. Example 4. I added 1 to both sides, and then I multiplied by the reciprocal of 3 using 3/2. I get the statement x is less than or equal to 36. I put a solid dot on 36, decided that 35 would make my statement true, so I drew my arrow pointing towards the 35 side. In question 5, subtract 5. Divide by -4. I divided by a negative, so that means that my inequality sign flipped around. So I now have to graph this inequality, put an open dot on -4. I'm going to test on either side of -4, and I end up that this true statement says -5 is smaller than -4. So I draw my arrow pointing towards -5. And number 6, I'm leaving the x where it's at. I'm adding 9 over. Dividing by 2, the x started on the right side of the inequality. It stays on the right side of the inequality. This means I need a solid dot on 1. If I test 0 and 2, the statement that makes sense is that 1 is smaller than 2, so I draw off to the right. In question 7, subtract the 6. I have to get rid of the fraction, so I multiply by the reciprocal of 1/3, which is 3. So I have the statement -15 is greater than x. Put an open dot on -15. I test -16 and -14. The true statement is that -15 is bigger than -16, so I'm going to draw my arrow pointing towards the -16. In question 8, leaving the x where it's at, I subtract 10. This is negative 1x, so I have to divide by negative 1. And because I divided by a negative 1, I had to flip the inequality sign. So now I've got an open dot on 23. I have to test 22 and 24. The true statement is that 23 is smaller than 24, so I drew my arrow to the right. And our last example, add 4 over, divide by 1.6, and get the statement x is smaller than 3. So I put an open dot on 3, test 2, test 4. I find out that 2 is the true statement. 2 is smaller than 3, so to draw your arrow to the left. And that is our first lesson. Hopefully all of this is review over graphing inequalities, writing an inequality given the picture, and doing some basic solving.